Welcome dear viewers to the video on design of experiments, and it is abbreviated as DOE. Design of experiment is a technique used to optimize the formulations, to optimize the process in the pharmaceutical industry, and DOE is used for the research work and to understand the different experiments and cause and effect relationship between the variables. This video will cover the basics related to DOE. DOE is a scientific and systematic approach to process and product optimization. We are going to see what is design of experiment, what is the importance of DOE, and how the DOE is executed in different steps or stages. Then we'll see key concepts in DOE, conclusion and best practices for DOE. What is design of experiment or DOE? If this question is asked to you, then you should answer like definition of DOE you should give. DOE is a systematic approach for planning, conducting, analyzing, and interpreting the experiments to understand and optimize the processes or systems. See, in the research work, you have to perform different experiments to make something happen or to understand some processes, to optimize some parameters or to optimize level of certain variables or independent variables. You need to understand cause effect relationship between the factors and variables. So this DOE gives a systematic approach to plan your experiments, to conduct your experiments. Then once you complete the DOE experimentation, you will have some data. That data is to be analyzed and the results are interpreted to understand the optimized parameters for the process or composition of the formulation. The purpose of DOE is to identify relationship between factors. These factors are independent variables and the responses. These are the dependent variables. For example, if you want to study the effect of controlled release polymer on the dissolution, then the level or concentration of the polymer will be independent variable and the percent dissolution at specific time point will be a response. Another important purpose of the DOE is improving the processes and products by systematically varying the conditions. In the field of science, in the field of research, we should have the experiments which are controlled and which are systematic. If we don't control the experiments, don't control the experimental conditions systematically, then the results cannot be correlated and we cannot optimize the process or system. So, design of experiment gives you the systematic approach for experiment conduction, planning, and interpretation of the results. Key features of DOE are controlled experimentation, statistical analysis, and optimization of the responses. So, in simple way, you can say that it is a tool for making the systematic and controlled experimentations. DOE is a tool for QBD in the pharmaceutical industry, and DOE helps to understand the effect of factors on the responses to have quality product manufactured. So DOE is a QBD tool as well. Why DOE is important in the pharmaceutical industry? Because it is efficient in problem solving. It helps to identify key factors affecting outcomes quickly and effectively. Optimization helps or enables for fine tuning of the processes for higher efficiency and better results. It helps to have cost reduction and cost effectiveness. It reduces unnecessary experimentation by focusing on the critical factors. It improves the quality and it is a tool for quality by design. It consistently leads to better, more reliable results. It reduces variability and helps to identify the sources of variation and how to minimize them. So it is the importance of DOE. If you have many factors affecting many variables, then it will become very difficult to understand the combined effect of factors onto the different responses. For example, if you are working onto a formulation with BCS class 2 or 4 API, so the particle size of the API will be a factor, then binder will be a factor, disintegrant will be a factor, lubricant will be a factor for the tablet formulation, and the responses will be assay, contain uniformity, dissolution, and related substances. So if you go by OFAC trials, it will be difficult to understand the combination impact. So that time DOE will help you to segregate the critical factors and to study the impact of each variable onto the responses. And DOE is performed in a systematic way. So now we will see what are those steps for performing the DOE. Step 1 is define the objective. We should have clear objective that what we are trying to achieve, whether we are trying to optimize the process, whether we want to reduce defects, increase efficiency, or for example in the formulation R&D, what type of dissolution is required, how much uh, dissolution at specific time point is required to be achieved, or impurity profiling. So these are the objectives. Then problem identification. Understand the problem and what specific question the experiment is answering. If you want to study the effect of polymer on drug release profile of the control release formulation, then you should understand that the polymer level will affect the dissolution. So this is understanding of the problem or problem identification. Establish clear goals. Example, maximizing production output, improving the product quality, or minimizing energy consumption. In the pharmaceutical field, the clear goals may be like having the specific release of the API at specific time interval. Step 2 is identify key factors, levels and responses. So for example, as I am taking here for a control release tablet, polymer level will have impact onto dissolution. So factors, levels and responses are to be identified critically. Factors are the variables that influence outcome. For example, polymer level, temperature, pressure, material type, it may be any variable that could impact the outcome. Levels, different setting or values of each factor, high, medium, low or specific numerical values. For example, if you have the middle value for polymer level like 20%, so you can set like 12% minimum or 15% minimum and 25% maximum level of the polymer. Responses, measurable outcomes that determine success. That may be percent release at specific time point, yield, strength or efficiency. Example here I have taken for process, factor, temperature, factor to pressure and response will be yield. So for example, temperature and pressure impact onto the chemical reaction yield. The third step is choose the experimental design. So based on the complexity of the formulation and based on the outcome, we choose the experimental design. Design types may be screening designs, optimization designs, and many others. Screening designs are used to identify significant factors that influence the responses. Example is factorial design and fractional factorial design. Optimization designs are fine-tuned for fine-tuning the processes to optimize the outcomes. So optimization designs are also there, like response surface methodology and mixture designs. Response surface methodology is called as RSM, and mixture designs are there which are done for optimization. Design selection criteria. So type of problem, number of factors, available resources and time, and desired precision are the key factors which affect the design selection. If you don't have many number of factors, then you can go for screening designs. If you have different factors which affect different variables, then or responses, then optimization by response surface or mixture design is done. Step 4 is randomize and replicate. Randomization means randomly assign the experiment runs to eliminate bias from uncontrolled variables and systematic errors. Replication means repeat experiment to account for variability and enhance reliability of the results. Replication also helps to estimate the error and improves precision. So randomization is mainly done in the trials or experimental runs to eliminate the bias and to eliminate the errors. And replication is to reconfirm the variability in the results. Then step 5 is conduct the experiments. Now you have done the randomization and replication, and now you have the experiments in your hand. So carry out the experiment exactly as you have designed. Follow the randomization and replication plan to reduce the bias, and then record the data. So collect the data, record the data accurately for each factor and the response. Step number 6 is analyze the data. Statistical analysis. Statistical analysis involves ANOVA, regression analysis, graphical tools can be used. ANOVA is analysis of variance. Test for significance of the factor effects. So ANOVA or analysis of variance is for testing for significance of factor effects. Regression analysis is to analyze the relationship between factors and responses. Graphical tools use plots, interaction plots, residual plots to visually assess relationships. Identify significant factors. Which factors have the greatest impact onto the response? Which interaction between factors are critical? So for identifying the significant factors, these statistical analysis techniques are used. Number 7 is interpretation of the results. So main effects and interactions are to be studied. What are the primary influences on variables or response variable? How do factors interact and influence the outcome? Optimization, identify the setting and maximize or minimize the response. Example is use contour plots or 3D plots or surface 3D surface plot to visualize optimal conditions. Step number 8 is validate and confirm the findings. Confirmation runs. Perform additional experiments at the optimal settings to verify the results. Once you have the optimized experiment condition, then you should reconfirm the same. Then perform cross validation. Test the findings under different conditions or on a larger scale to ensure consistency. Robustness testing to ensure that the optimized conditions are reliable in real world applications. So this is the validation and reconfirmation for the findings. If you have performed the DOE for optimizing the polymer level for control release formulation, that time you should make certain batches of the same polymer level to understand and reconfirm or validate the findings of that polymer level. and study that the repetition of the batches is providing you or giving you the same results. So that is validation and confirmation findings. Also in pharmaceutical industry, you can perform experimentation of DOE at small scale and make validation, reconfirm it, and then go for scale up with the same formula so that you will understand what is the robustness of the product and process polymer level and how is the behavior of the optimized composition or polymer level when the scale is increased. Step number 9 is implement and monitor. Apply the optimized settings or solutions in the production or operational environments. Continuously monitor, track the performance and ensure the results are sustainable over time. Make adjustments if performance begins to deviate. So once you have the optimized composition, perform scale up, understand the product behavior in the actual production environment, and then continuously monitor the same. Continuously improve based on the performance of the batches and the data available time to time. Document and report. So record all the experimental details, methodology, data, results, analysis, and conclusions, and share the findings with stakeholders. Your stakeholders may be management, teams, clients, or if you are a student, your stakeholders will be your research evaluation team members. Then highlight key insights, improvements, and recommendations. So key concept in DOE we will see. So key concepts are factorial design, fractional factorial design, response surface methodology, Taiguchi method. In fact, factorial design, test all possible combinations of factors and levels. Fractional factorial design is a subset of factorial design, testing only a fraction of the combinations. RSM method involves a collection of statistical techniques for modeling and analyzing problems where a response is influenced by several variables. For example, if dissolution is impacted by the particle size, binder level, disintegrant level, lubricant level, hardness, that time you should go for the response surface methodology. Another one is Taguchi method, a robust design approach that focuses on minimizing variation and optimizing the performance. So if you want to learn DOE, you need to practice it with some softwares and you should apply the knowledge of DOE in your daily experimentation. Then only you can understand the topic in a detailed way. In conclusion, DOE is a powerful tool for improving the process efficiency, product quality, optimizing various systems, and optimizing the formulations and processes in the pharmaceutical industry. By following a stepwise structured approach, DOE minimizes experimentation time and resources while it delivers you reliable and repeatable results. A systemic DOE approach ensures that results of your experiments are valid, repeatable, and provide a real world benefits. Best practices for DOE start with a clear objective and problem definition. Keep experimental design simple and focused. Use randomization and replication to reduce bias and error. Validate results with confirmation runs and cross-validation. Continuously monitor the processes after implementation to ensure sustained improvements. So these are the things which we need to understand for design of experiments. I hope this video will help you to understand this topic. Thank you for watching the video and let's meet you soon with such kind of informative video. Thank you.